Hi students. So today I am going to talk on permutations and combinations. So I am going to discuss permutations and combinations for your competitive exams. That may be your IIT exam, or that may be your COMEDK exam, or that may be your any state competitive engineering exams. Clear students? So for that I am going to discuss your concepts permutation and combination. Before starting our permutation and combination, in every exam on this permutation and combination you are going to have one question or two. Clear? One is minimum, two will be the maximum on permutation and combination. If they are asking two questions, it will be from one to permutation and another one from combination. Clear? If they ask only one, they may ask from permutation or they may ask from combination. Otherwise, sometimes they can ask the questions on the basis of where both permutation and combination are going to be used in a single problem. Clear students? So in this way they are going to ask in your exams. So for that reason today I am going to start permutation and combination. In this chapter, first we shall study about permutations. Clear students? First we shall study about permutations and next we shall go to combination. Clear? So first we shall go one by one the concepts of the permutation and let us discuss all the things of permutations in detail and let us solve the questions which have occurred in previous exams. After that we shall go for combination. Before going to again the permutation, you must know some basic concepts and notations. What are those some basic concepts? One is factorials. One is factorials. That means you must know what is factorials. Clear? Next, you must know fundamental principle of counting. Clear students? Fundamental principle of counting. Fundamental principle of counting. Clear? So these basics you must know before going to any permutation or combination concept. So if before I am going to start permutation, I will first go for factorials, next I will go for fundamental principle of counting, and then I will go for the definition of permutations, because these two are very essential things to understand what is permutation. Clear students? So now factorials means it is a very simple concept that which says the product of the number of elements. That means the product of number of elements means if I write 2 factorial, this is nothing but 1 into 2. If I write 3 factorial, it is nothing but 1 into 2 into 3. If I write n factorial, it is nothing but 1 into 2 into 3 into so on to n. Clear students? So that is n factorial is 1 multiplied with 2 multiplied with 3 so on to multiplied with n. 2 factorial means 1 multiplied with 2. 3 factorial means 1 multiplied with 2 multiplied with 3. Clear students? So this is what your factorial term tells. Clear? So factorials means the multiplication of the given number with the previous numbers. That means if I give n as integer to you, which is positive integer, so if I give any natural number n to you, and if I say n belongs to natural numbers, and if I say to find the factorial, your n factorial will be 1 multiplied with 2 multiplied with 3 multiplied with so on to n. So that is what your n factorial. Please students, here this is n, previous number will be n minus 1, previous number will be n minus 2. Please remember that. Clear? While solving the terms, it will be very essential things to know that before n minus 1, before that n minus 2, before that n minus 3, so on. So that is what your factorial terms. Clear students? Factorial means that is the multiplication of the given the multiplication of the given number with its previous numbers. Clear? So that is n factorial is given by 1 multiplied with 2 multiplied with 3 so on to multiplied with n. Clear? If I write for example 2 factorial, it is 1 into 2. If I write 3 factorial, it is 1 into 2 into 3. Now coming to fundamental principle of counting. Here you have two terms. One is multiplication and another one is addition. Clear? So fundamental principle of multiplication and fundamental principle of addition. Now for example, if I take one problem, that is person is wearing, person is dressing himself with 3 shirts and 3 pants. Clear students? 3 shirts and 3 pants. So in how many number of ways that particular person can dress himself? Clear students? So that is person is dressing himself with 3 number of shirts and 3 number of pants. Then how many number of ways are there to make his event complete? That is, in how many ways he can dress up for himself. See here, event is depending on each other. That means he has to wear shirt also, he has to wear pant also. Are you getting my point? Here both the events are depending on each other. He can't wear only shirt, he can't wear only pant. Are you getting my point? If he has to be dressed, that means the complete event has to be done. In that situation, these two terms are depending on each other. They are not independent on each other. In that particular situations, it is having dependency on each other. That means either he wear pant first, shirt first, no problem. But if the task has to be completed, he has to be taking both the events in depending form. For example, if he take 3 shirts, from these 3 he can wear any pant, no problem. If he take 3 pants, from these 3 pants he can wear any shirts, no problem. Are you getting my point? So here, if I take S1, S2, S3, P1, P2, P3, this type of terms, that means S1 means shirt 1, shirt 2, shirt 3, pant 1, pant 2, pant 3. Here you have with shirt 1 3 choice. Clear? With shirt 2 again he has 3 choice. With shirt 3 again he has 3 choice. Are you getting my point? So total S1 has 3 choice, S2 has 3 choice, S3 has 3 choice. Clear? So all shirts are having, each shirt is having 3 pants as a choice. Again pant 1 has 3 choice, pant 2 has 3 choice, pant 3 has 3 choice. So here total number of possible cases are 3 into 3, that is 9. Because here the event is dependent event. Are you getting my point? So in the form of dependent events, your fundamental principle of multiplication will be carried out. Are you getting my point? Fundamental principle of multiplication is going to be used whenever the event is dependent. Clear students? So in that cases we use the multiplication principle, the fundamental principle of multiplication. Clear? In counting we use the fundamental principle of multiplication. Here fundamental principle of multiplication means if A event has m ways, next if B event has n ways, the event will be that the event the event B has to be done by the A has already done. Clear? The event B has to be done whenever the A is already done. Clear? So therefore B is depending on A. Are you getting my point? B is depending on A, B will be done only when A is done. Are you getting my point? B is done only when A is done. In that particular situations, it will be depending on each other, and we are going to use fundamental principle of multiplication. That means A event has 3 ways, B event has 3 ways. The event B has to be done depending on the event A. In that particular situation, we use fundamental principle of multiplication. Therefore, the fundamental principle of multiplication says that the number of ways to complete the event is n of A into n of B. The number of ways of A into the number of ways B. Clear, students? So that is going to be your fundamental principle of multiplication. Very, very important. Please remember that. Clear? Next, here we got to know that fundamental principle of multiplication is, if the person P is dressing himself with 3 pants and 3 shirts, the total number of the ways are 3 into 3. That is 9 number of ways. So here he is having 9 number of ways. 9 number of ways to complete dressed up. Clear, students? So this is what fundamental principle of multiplication. Now let us go for fundamental principle of addition. Fundamental principle of addition. So for multiplication I will write dependent event. Dependent event. Clear? So dependent event. So for the multiplication, the event has to be dependent. The event B must to be depend on event A. So that reason, the number of ways will be equal to n of A into n of B. The number of ways is equal to n of A into n of B. So now let us go for addition. For addition, again I will take one simple example for the clarifications of fundamental principle of addition. Now let us take, there is a lady, he has to go for shopping. There is a lady, he has to go for shopping for 2 places. Lady is shopping in 2 places. That means she is going for 2 places. Let us consider place 1 has 3 shops. Are you getting my point? Clear? Place 1 has 3 shops. Place 1 has 3 shops and place 2 has 2 shops. Place 1 3 shops. Place 2 2 shops. Clear? So now she should make her shopping complete. See here, she can complete her shopping by making the shopping at 3 places or making a shopping at 2 places. There is no any dependency of either she go for shop 1, she should go for shop 2, like that. There is no anything. So there are 3 shops in place 1, S1, S2, S3, and another shops, this is place 1, again S1 and S2, this is place 2. Clear? So place 1 has 3 shops, place 2 has 2 shops. Now she is going for place 1. And she makes shopping in all 3. The event 1 is over. That means she goes for place 1 and she makes a shopping in all 3 shops. Therefore the event is over. Clear? Again she comes for P2. She makes in both the shops shopping. Clear? That means S1 and S2 in place 2. Here she went for 3 shops. Here she went for 2 shops. Clear? In the previous problem, pant 1 and shirt 1. That means if he wears a pant, to complete his event he has to wear a shirt. If he wear pant 2, he has to wear a shirt. If he wear pant 3, again he has to wear a shirt. That means P1 has 3 choice, P2 has 3 choice, P3 has 3 choice. Clear? But here there is no like that. If she goes for shop 1, there is no need of going to shop 1 in P2. if she goes for shop 2 in P1, that means place 1, there is no need to go for other shops. Are you getting my points? So here what we are doing, we are calculating the total number of the ways in which she can make her shopping. Are you getting my point? So total we have 5 shops where she can go from 2 places. That means in how many ways she can do her shopping? She can go for shop 1, she can go for shop 2, she can go for shop 3, she can go for shop 4, and she can go for shop 5. Are you getting my point? So like that, she has total 5 number of shops. So there, if I add all those, therefore she has 5 ways of her shopping. Are you getting my point? So here the event is independent. Here the event is independent. In addition, the event is independent. In addition, the event is independent. In the multiplication, the event is dependent. In the multiplication, the event will be dependent. In the addition, the event will be independent. For example, the shopping of lady. For addition, for multiplication, it will be the wearing of dress or getting a dressed up. Clear? The simple examples. With those simple examples, I think this is clear for you for multiplication and addition. Fundamental principle of multiplication and fundamental principle of addition. Clear, students? So whenever you are using fundamental principle of multiplication, both the events must be independent. For example, event A and event B are independent to, event A and event B are dependent to each other. Then the fundamental principle of multiplication says that n of A into n of B will be the total number of the ways of your possible cases. If the event A is independent of event B, then the total number of the possible cases will be n of A plus n of B. So that is what your fundamental principle of counting tells. Clear, students? I think these things are very much clear with you. Fundamental principle of counting and fundamental principle of counting for addition and multiplication. For multiplication, remember dependent. For addition, you remember independent. Clear? Again, factorials, that means n factorial is nothing but 1 multiplied with 2 multiplied with 3 multiplied with so on to n. Clear, students? So now let us try to solve some of the problems on depending of this simple concept of fundamental principle of counting. Fundamental principle of counting. Clear, students? Okay, students. So now let us go for your first problem, that is 5 buses run from Bangalore to Pune. Clear? There are 5 buses which run from Bangalore to Pune. If man goes from Bangalore to Pune, that means if a man goes from Bangalore to Pune and comes back with other bus, what are total number of possible cases they are asking. Clear, students? There is a man who goes from Bangalore to Pune and comes back with the other bus. That means what he leaves that bus and he comes with the other one. Clear? So total he has 5 number of buses. Clear? He goes from Bangalore to Pune. That means he goes from B to P, that is Bangalore to Pune, with 1 bus. Out of how many? 5. That means he has 5 choice to go Pune. He has 5 choice to go Pune. While coming back, if he goes with 1 bus and he leaves that bus and he comes with other 4, that means he has again 4 number of ways to Pune to Bangalore. Clear? Clear, students? Here he has 5 ways. Here he has 4 ways. From going to Bangalore to Pune, he has 5 ways. To return from Pune to Bangalore, he has 4 ways, because total he has 5 ways. Total he has 5 buses in between Bangalore to Pune. So he goes from one bus to Bangalore to Pune. That means he has 5 choice to go. Again to return, he has 4 choice. This is to go and this is to return. Clear? He goes with 5 ways, he comes back with 4 ways. That means, please remember, here the event is dependent. Are you getting my point? Here the event is dependent. If this event has to be over, that means if this event has to be done, he has to go to Pune and he has to come back. Are you getting my point? After going to Pune, he has to return to Bangalore. Are you getting my point? So here the event is dependent. Clear? He can't go Pune and he live there. Are you getting my point? According to our problem, he has to go for Pune and he has to return to Bangalore. Are you getting my point? If he goes to Pune, if he comes back to Bangalore, he has 4 ways for returning, 5 ways for going, because total number of 5 ways in between Bangalore and Pune. So total number of the ways will be what? 5 into 4, that is 20 ways. Clear, students? Because here we have to use the fundamental principle of multiplication. Here we have to use fundamental principle of multiplication. Are you clear? So this is what you have to understand in particular problem. You have to go through the problem in detail and you have to understand. Clear? In particularly permutation and combination. Very, very important topic. Clear, students? So please remember that this is dependent event. The fundamental principle of multiplication is used so that he has to come with 20 ways to complete this particular event. Clear? So therefore 20 is your answer. Therefore he has 20 number of ways. Clear, students? So in further I will discuss fundamental principle of addition also whenever we are going to use in problems. So after the definition of permutation, I am going to use some problems. I am going to do some problems. In that particular problem, I will discuss that particular fundamental principle of addition. Now you know that what is fundamental principle of multiplication. I discussed the dressing up. And now I am discussing this particular problem. So this type of problems are done with fundamental principle of multiplication. So be perfect with this. Okay, students. Now let us go for permutation. Clear? So here, if I want to explain you permutation, you must understand that concept. For understanding your concept of permutation, I will give a simple example. That means I will give you some number of objects. I will give you some number of objects and I will tell, take out R elements. That means take out R objects from that n number of objects which I have given to you, and you should arrange those R number of objects. Are you clear? That means you should take from me n number of elements or n number of objects, and out of that n you should take out R number of objects. That means I will give you n objects. I will give you n objects and you should take this n objects and you should take R, take out R number of objects and you should arrange them in order. Clear? That means arrangement, or you can say or selection. Clear? Arrangement or selection. Selection means from this n object you should select R number of objects. Are you clear? So from that you can say that out of n objects you should select R, or you should arrange R number of elements. That type of process is called permutation. Are you clear, students? we write the notation of NPR for the permutation, that is n number of the objects you are arranging or selecting the R number of objects from n number of elements. Please remember, this R must be always lesser than or equal to n. R must be always lesser than or equal to n. R cannot be greater than n. Clear students? Because you are selecting or you are arranging R number of elements for the given n number of elements, therefore R should be always lesser than or equal to n. Clear students? So from n number of objects you are selecting or arranging R number of objects. That type of thing is called permutation. Permutation means selecting or arranging. Have you understood? So permutations means what? It is selecting or arranging the terms in order. For example, let A, B, C be the three objects. Let A, B, C be the objects. Then let us take 2 out of these 3. Choose 2 objects from, or select 2 objects from A, B, C. From A, B, C. Then tell me what are the total number of permutations. Clear? Let A, B, C be the 3 objects. Select 2 objects from A, B, C. Then what are the total number of permutations? Then what are the permutations, or what are the number of ways? What are the ways of selecting 2 from A, B, C? That is 3. Clear students? So here let A, B, C be the 3 objects. Select 2 objects from A, B, C. Then what are the ways? Then what are the total number of the ways of selecting 2 from A, B, C? That means what are the ways of selecting 2 objects from total number of 3 objects? Otherwise A, B, C be the 3 alphabets and select 2 alphabets from A, B, C. Like that also you can say. So here please see how I will arrange those terms. Clear students? I will take A, B first. I will take A, C next. No problem. I will take B, A first. I will take C, A next. No problem. Now what I will do? I will take C, B first and I will take B, C next. No problem. So these are the total number of the ways of selecting or arranging. Are you clear? So that means you can arrange them as, see, AB, BA, AC, CA, CBC, CB. So these are the total 6 number of arrangements or 6 number of selections of your 3 number of alphabets or 3 number of objects, that is ABC. Now what will happen with NPR? That is 3P2. Clear students? Please remember one formula, that is NPR equal to n factorial divided by n minus r factorial. Here NPR is n factorial divided by n minus r factorial. I am not going to solve this in detail. Directly I am going to write the formula to use in our problems. So please remember this, NPR equal to n factorial divided by n minus r factorial. So that will be 3 factorial divided by 3 minus 2 factorial. So therefore this will be 6. Clear students? 3 minus 2 is 1. 1 factorial is again 1. Remaining with 3 factorial, 1 into 2 into 3. So totally you are having 6 ways. See, here already we have arranged 6 ways. Clear? So permutations means the formula will be NPR. The notation will be NPR. Formula will be n factorial divided by n minus r factorial. Clear? Permutations means selection or arrangement. Permutations means selection or arrangements from the given number of objects. That is what? Clear? Permutation is the process of selecting or arranging the number of r elements from the total number of given elements. So that will be your permutation. Clear, students? So please be perfect with the definition of permutation, that is the selection or the arrangement of r number of elements with total number of n number of elements.